and welcome to Long COVID Foundation podcast. This is the channel where we share educational information on long COVID to help you get answers relevant to your symptoms. And if you're new to the channel, make sure you hit subscribe button because it will help me get answers relevant to your symptoms. And one more thing. Due to numbers of long haulers globally reach over 180 million to date, we want this channel to be more visible to everybody. So by simply liking and sharing our videos, you will help many out there. Our channel will be easier to find among the general YouTube search. So 3 simple things you can do to support our charity. Subscribe, like, and share. Thank you to all of you. For the autism, it's really interesting because I noticed through years there are more and more children developing autism, even without any genetics involved into this process. So I know you mention autism quite a lot in your research. So what is the driving mechanism between, or the link between, the glyphosate and autism condition in children? It's really interesting.
It's a very interesting topic, and there are many ways that it disrupts the gut to cause problems. But I've actually zeroed in on one that is quite under-recognized, that I believe may be the central feature of autism, and it has to do with sulfate. Glyphosate, I believe glyphosate is an absolute train wreck for sulfate. That's what I'm seeing from all the data, and I talk a lot about that in my book. And again, it has to do with this issue of getting into proteins by mistake in place of glycine. And it specifically gets into the way in proteins that bind phosphate at a site where glycine is highly conserved. That's a pattern. I call that a glyphosate susceptibility pattern. And it turns out that many of the proteins that are involved in managing sulfate have that glyphosate susceptibility feature. And studies have shown on E. coli have shown that those enzymes are affected. Suppressed by glyphosate. And I suspect that's happening by virtue of glyphosate substituting for that glycine residue. That will prevent the protein from binding to phosphate. And what the problem is that there are all these nucleotides, that ATP binding, GTP binding, there are all these proteins that bind phosphate at critical sites where they have motifs that contain critical glycines in them. This is well established in the research literature. And so I think glyphosate is messing up those proteins. It's very clear to me why it would mess up the protein that converts sulfate into its activated form. And that activated form is what's called the universal sulfate donor. And that's basically a combination of an ATP molecule and sulfate. It's an ATP energized sulfate, which allows it to react. That molecule goes around and transfers sulfate from one molecule to another. So there's a sulfotransferase that will take the sulfate off of this activated sulfate, which is called PAPS, PAPS. And then there's the enzyme that actually makes the PAPS, and even the enzyme that removes the product of the PAPS in order to get back to the cycle. All of them are going to be disrupted by glyphosate, according to my theories. And as I said, there's evidence in the literature to support that. And so what happens is sulfate synthesis is impaired as well, sulfate activation to produce this energized sulfate molecule, and then sulfate transfer from one molecule to another. I think all of those enzymes are disrupted by glyphosate. Sulfate becomes systemically deficient. And this is super, super critical. So the other thing is that there are all these fat-soluble molecules. Typically, they have rings. It's the benzene ring base for a huge number of molecules in the body that are fat-soluble, unless you start doing modifications to them to make them water-soluble. And a critical modification you can do is to stick a sulfate onto them. And when you do that, so all of these molecules, there are many molecules that are biologically really important that are transported with a sulfate attached to them. And when they're delivered, the sulfate is removed. And all of these enzymes are disrupted by glyphosate. And that sulfate is then attached, for example, to the glycocalyx. So lining all the blood vessels are all these complicated sugar molecules, sugar chain molecules that have sulfates attached to them, called heparin sulfate, chondroitin sulfate. Glucosamine sulfate is one that you can take as a supplement. All of these sulfated molecules are populating the lining of the blood vessels. And they're very, very important to make the circulation work correctly. And heparin sulfate in particular is one I've really zeroed in on. And what I found from the research literature, multiple studies have shown Specifically, heparan sulfate is severely deficient in the brain ventricles, where the cerebral spinal fluid is, the severely deficient heparan sulfate in the brain of autistic kids and also of autistic mice. They have these mice that have a kind of a mouse version of autism. They also have this characteristic feature of defect, insufficient supply of sulfate to the heparan sulfate in the brain ventricles. And you can see that people have shown in studies that heparan sulfate is absolutely critical for the development of the brain. The neurons mature out of that area and grow and go to their proper place in the brain as it's being formed. And that critically depends on an adequate sulfation of that heparan sulfate. So I think that's central to autism. And I think that glyphosate very clearly disrupts that whole system. And that is a major feature of what causes the autistic brain to be not working correctly.
From your research again, would you refer to a particular species of bacteria overgrowth in autistic children, something that parents maybe could do tests and look for something specific?
I would name three: Clostridia, D-sulfovibrio, and Bilophila wadsworthia. All three of those have been associated with autism. There's others as well. I mean, their gut is always very, very complex, but those three I have singled out because they've also been associated with glyphosate. And so particularly D-sulfovibrio and Bilophila wadsworthia both reduce sulfate to hydrogen sulfide gas. Sulfate and sulfide get reduced to hydrogen sulfide gas by those microbes. And that is happening because the system that would take that sulfate to the activated form and attach it and send it out is broken. And so the sulfate and sulfide pile up, and you have to remove them. And the way you remove them is by reducing them to hydrogen sulfide gas using these microbes. So the autistic kids have excess bloating in their gut, and that is often related to excess hydrogen sulfide gas, which is produced by these sulfur-reducing bacteria there. And so, in fact, not only the oxidation of sulfide to sulfate, but also the reduction of sulfide, its incorporation into methionine, is also broken by glyphosate. That's been shown in studies even on plants. The aromatic amino acids, but also methionine, is the base of the sulfur-containing amino acids. For example, it produces cysteine, and cysteine gets incorporated as a super important antioxidant defense in the liver and elsewhere, including the brain. And so methionine synthesis by the gut microbes gets destroyed by glyphosate. And instead, the sulfate gets reduced to hydrogen sulfide gas by these bacteria that overgrow. Clostridia has been shown. There's an interesting study that showed, it was a study on a set of triplets, 2 boys and a girl. And all 3 of them had high levels of glyphosate in their urine. The 2 boys were diagnosed with autism. The girl had a seizure disorder, and they had overgrowth of Clostridia in their gut. And the author proposed that the Clostridia was producing metabolites, such as p-cresol, that are phenol-based, benzene-based metabolites that are toxic, and that those metabolites were getting into the brain and disrupting it. And I will say that those metabolites need to be sulfated in order to be detoxed. And that also gets stuck because of the glyphosate. So those become toxic because the liver cannot sulfate them, cannot make them water soluble so they can be removed through the kidneys. So this is really a horrendous situation where you're both getting excess toxicity of things that are toxic. I mean, for example, Tylenol is another one. The autistic kids are unable, and that's been shown in a study as well, that they were unable to convert Tylenol into Tylenol sulfate, which is what you need, acetaminophen, I guess it's called sulfate. They couldn't do that. And that causes that to become toxic as well to the liver. So many fat-soluble molecules that are normally considered to be toxic, including a lot of insecticides, for example, and various metabolites that are produced by these bacteria, they need to be sulfated in order to be cleared. And that's where things really go south with the autistic kids.
Unbelievable. Thank you, Stephanie. This is really amazing. And I'm sure our doctors not quite aware of all these links, and the research that you do is truly appreciated, because we need more and more scientists like you who are doing extensive work on linking real causes, not just labeling children with autism just because they're not very good at learning or any other things, but looking deeper. And understanding what is really happening. So thank you for this overview of autism as a condition. So